Hi, I'm Mia. Come meet the GMU Raytheon competition team. This is our lab. Every year, Raytheon hosts an autonomous vehicle competition on the East Coast for undergraduate research teams. This year, the competition is GPS denied. This is our indoor drone and ground vehicle. And this is our team. Let's talk about the competition.
Hey guys, Luis here. This year's RTX Autonomous Vehicle Competition is going to be hosted at Eagle Bank Arena, where indoors we obviously can't use GPS. This is going to make it a lot harder than the previous year's competitions. Let's talk about some of the challenges we'll face this year. Challenge 1. The UAV must autonomously take off from the ground vehicle. After it is launched, the ground vehicle will begin moving at a consistent pace while the UAV lands on it. Challenge 2. The UAV will take off from the ground vehicle, search the field for an UCO code, and then communicate that position back to the ground vehicle. While the ground vehicle is moving to that position, the UAV must land back on it. Challenge 3. The UAV takes off from the ground vehicle again, searches the field for a UCO code, communicates that position back to the ground vehicle, and while the ground vehicle is moving to that position, it has to dodge obstacles and the UAV has to land back on the ground vehicle. Now to Logan to talk about our ground vehicle.
Oh hey, I didn't see you guys there. I'm Logan, the ground team lead, and this is our UGV. Here at the back, we have a Raspberry Pi 5 with the brain chip installed. Together with our Jetson Orin, they're able to allow for maximum object detection using the Azure Connect camera. Now all of this is possible because we tore down an RC Jeep and were able to place our beautiful landing pad on top with its Aruco tag for our drone to home in and land on it. On to the drone team with Mia.
This is our drone. Without GPS to fly indoors, we rely on visual inertial odometry. We use this RealSense camera and IMU data in order to create a position estimate on the field. Our secondary source for positioning is the ArcFlow, which incorporates optical flow and LiDAR sensors. We also have a downward-facing camera for Aruco tag detection to find our target location and to land on our ground vehicle. All of this data is processed by our Jetson, which communicates with our Orange Cube flight controller in order to fly the drone. Now over to Adith with software.
Hi, I'm Adith, the software guy. I help manage the team's software. I manage stuff like the simulations. This is our simulation website. We have it so we can record the simulations and test all of our code in sim before we actually put it on the drone. We use Gazebo along with Ubuntu 22 to run all of our simulations. I also help with the actual software that's on the drone, along with the software on the brain chip. The brain chip is the thing that helps the ground vehicle object detect and move around. One of the biggest problems that we have with our drone is that it needs to be able to find where the ground vehicle is. So we attached an Aruco tag on our ground vehicle. I use OpenCV to help the drone find the ground vehicle and center itself over the ground vehicle. So when it lands, it'll land on the ground vehicle. I offset the drone a little bit so it's in front of the ground vehicle. That way when the ground vehicle passes under the drone, it can correctly land on the ground vehicle without missing its platform. Over to William.
All right, here's what sets our system apart from other teams. The first thing that we're doing that's special, on our UGV, like Logan was talking about, we have an Aruco tag. That lets the UAV follow the tag and land on it without having to communicate the two positions. That lets us save bandwidth and save resources. On our drone, we're using RTAB map to figure out where the drone is and map the competition space. It lets us close our loops so that we know where the drone is at all times and we don't just move forward in space constantly. And it lets us create a map with those coordinates to send to the UGV so that the UGV knows where the target Aruco tag is. We also have a lot of built-in redundancies in our system to make sure that it's robust. We have a VO camera on the front to know where the drone is. That's supplemented by an ArcFlow camera facing downward that lets us figure out where the velocity and the height is. We also have an indoor geofence to make sure that we are safe while we are flying our drone. Now to the cameraman.
Hey guys, I'm Luis. Over these last 8 months, we faced a lot of challenges, with our main challenge being learning new systems that a majority of us have never worked on before, such as how to use ROS, how to implement OpenCV to do our UCO detection as well as object detection, and how to implement visual inertial odometry on a drone. Some key takeaways we want to do for next semester is to have a better production pipeline. That includes intercommunication between teams, having a better finance plan, and having better project management. And to do this, we are implementing a new student organization called ARC. If you are a George Mason University student and you want to join the project next year, go look up Autonomous Robotics Club at George Mason University.
And we'll see you at competition.